Everybody, welcome back to another fun and exciting geometry class. Today we're going to be on page 74 in your books. So where we're going to begin, we're going to be talking about different things about proving angles equal. We've already had two ways to prove angles equal, and those ways were they could be corresponding parts of a congruent triangle, or they could be opposite equal sides in an isosceles triangle. Those are two ways that we have to prove angles equal. In this lesson, we're going to find even more ways. And even really in the last lessons, we started adding different ways to prove angles equal. If they were, opposite angles, we can prove that those are equal. If they are alternate interiors, we can prove that they're equal, stuff like that. So, but here is yet another way to prove that angles are equal. Now, the first thing we really have to kind of understand about this lesson is it might be a little bit challenging. So let's look down here and look at the two triangles that I have drawn on the board. These are very similar to the triangles that they have drawn in your book. Now, if I look at these, I need to quantify. I need to let you know which one is the side we're looking at. This is going to be the right side of the triangle. The right ray, the right side. Okay? Now, that makes sense in that one. The reason is because when you are here at the vertex, are you looking to your right or are you looking to your left? Okay, and I know that probably looks backwards because in the screen I'm looking at you backwards, but this is my right hand. This is the hand I write with. Okay, so I know it looks backwards, but anyways, right and left. When you're at A, when you're standing at the vertex and you're looking to the right, you're looking at C. Okay, and that's not hard to be able to look at this one and see that. So if you're standing at A and you're looking this way, you're looking to the right. Okay? Now, technically you're not looking to the left here. You're kind of looking still a little bit to the right. But this side is called the left side. It's more right, or it's more left than the right side, but it's not to the left, okay? But you have to understand this. You have to understand the concept here. Now, that's kind of easy to understand. Now, this one, it's a little bit more complicated because you got to like stand on your head and look at this thing or try to figure out some angle to look at this. You got to look at it. And remember when I told you postulate 5 says that you can turn things in space and not change them? Believe it or not, all I did on my program is I took that triangle and I rotated it. That's all I did. So it's a perfect copy. It's just rotated. So this is the right side and this is the left side. And you're like, nah, I think you've lost your mind now. Okay. Now remember, we're looking at it from the vertex. Right now you're looking at it from down here. And it makes sense that the one that I marked as the left, that you're thinking, no, that's the right because that's on the right side. No, put yourself here at the vertex. Again, you got to move your head around and look at the right side. Well, the right side is AC and the left side is AB. That's going to be, some of you are like, oh my goodness, geometry just messes with my brain every time I turn around. Geometry's messing with my brain. I know, and I'm sorry. That's what geometry's supposed to be doing. Geometry's supposed to be messing with your brain. So if it's not messing with your brain, it's not doing its job. So left and right, you need to kind of get that concept right here, because the rest of this lesson is contingent upon you knowing your right from your left in your triangles. All right, page 75. Theorem number 9. If two angles have their sides parallel, right side to right side, and left side to left side, then the angles are equal. All right, so let's go down here. So this would be the left side, and this would be the right side. And in this one's easy to look at too. Left side, right side. All right, so you're like, okay, I can handle that. Okay, good. So if I look at what this says, it says if two angles have their right sides parallel and their left sides parallel. So let's just kind of say that that's true, but let's extend these lines out. And I'm going to extend the line out in a different color. Well, I don't have to extend that one, but I'll extend this one. Well, I can extend that one both ways. All right. So now, can you see where they're parallel? These bottom angles are parallel, and these right side angles are parallel. Okay? So again, I just copied the triangle and moved it over, so I know that it's an identical triangle. But here's what the theorem says. The theorem says, if that's true, if this is parallel to this, and it is, and if this is parallel to this, and it is, then what is true? Well, then the angles are equal. This is a new way to prove angles equal. Okay, I want to show you something that's really neat. Okay, so maybe you already saw this as I was drawing those. So let's draw these ones right here. Okay, those are parallel lines. Now watch what this becomes. And I could do that in a different color. Let me do this in a different color. Watch what that line becomes. That line just became a transversal. Oh my goodness. I know, isn't it crazy? And that line became a transversal. And so we could go around this and we could number this 1, 2, 3, 4, 5, 6, 7, 8. So if we're following all this through, remember, so this angle right here is angle 8, which is a copy of this one out here, which is a copy of this one in here. They're all equal because these lines are parallel and they're being cut by a transversal. Some of you, I can't see your faces right now, but I know what your faces look like right now. You can't believe it. You're like, this class is killing me. All right, I know. I'm sorry. Just keep working hard, keep trying to understand, keep trying to do your best, because it is complicated. I remember being you. I remember sitting in your shoes in your class in 9th, 10th, 11th, 12th grade, trying to get concepts like this. And I was like, oh. And the teacher just made it sound so easy, and I was like, what in the world is this guy doing? Well, now I'm the guy that's trying to make it easy, and you guys are like, that is not easy. I know it's not easy, okay? It's complicated, and it's hard to learn the first time. But once you get it, then you got it. So keep working hard, keep doing your best, okay? All right, Theorem 9.1. Now what we have is two angles have their sides parallel, right side to left side. Now there's a change. In this one, it was left side to left side and right side to right side. Okay. In this one, it's now, so let's write left and right on this one again. So this is the left and this is the right. In this one, this is the left and this is the right. Okay. So now what they're saying is if left side is parallel to right side. Now again, let's extend this. You see how those are parallel, right? Okay, they're parallel. And look at these. These are parallel. Okay, but again, look what we have again. We have transversals cutting parallel lines. When we have that, here's what we have. Here's what Theorem 9, Corollary 9.1 says. If they are parallel right to left and left to right, which is what we have here, then the angles are supplementary, or they equal 180. Let's look at why that is. Okay, there's our parallel lines. and there's our transversals. So look what we have here. If this is angle 1, 2, 3, 4, and we number it around, this would be equal to this. And it would be supplementary to this angle right here. Supplementary means 180. Remember when we did that before? We said it's on a straight line, so it's 180. So if these two together are 180, then this one plus this one is 180. Okay? Because this one equals this one. So let's just, I mean, we could number these. So 1, 2, and 3. So 1 equals 2. Well, 2 and 3 together are supplementary. They equal 180. So then if 2 equals 1, then 1 and 3 are also supplementary. So kind of cool. This is all working together. I'm not sure what happened right there, but that got a little crazy on me. Okay, Theorem 10 says, if two angles have their sides perpendicular, right side to right side, and left side to left side. So now we're not talking about parallel, we're talking about perpendicular. So let's first of all write the right and the left side. So this is the right side, this is the left side. Okay, so spin our heads around and look at this one. This one would be the right side and this one would be the left side. Okay, so what they're saying here is that if right side is perpendicular, let me just use a regular line here. If that's perpendicular, and if this is perpendicular, okay, and they are, now I'm just kind of writing, you know, my lines aren't perfect there. But if they are, and they are, then it says that the angles are equal. The angles are equal. So if right side is perpendicular to right side, and left side is perpendicular to left side, which is what we're looking at here, then those angles are equal. And they are equal because all I did was basically, I'll just show you what I did. I mean, I just took this and I spun it around. I copied it. Okay, there's the copy. And there's the, I don't know, there it goes. And there's the spin around, and I just spun it around. So it's a copy. It's a perfect carbon copy of it. Okay? So it is a copy. And what happens when you copy it, when you spin it this way, is that if these are perpendicular, those are perpendicular 90 degrees, then this one will also be perpendicular 90 degrees. Okay? And so that is Theorem 10. That is exciting stuff. Didn't you have a great time today during this lesson? So much fun. All right, well, that's all I have for you. I hope you understood it. If you didn't, rewind it back, find the things that you missed, and try to watch them again. Try to understand this stuff because this is important as we're going forward. All right, we'll see you later. Bye-bye.